RCB reduces the time required to design and schedule columns by fully automating not just the calculations, but the entire design process. The user is provided with enough flexibility and transparency to give them confidence that they are achieving the most efficient design. Design and scheduling for large buildings is reduced from weeks to days, and small and medium buildings from days to hours. It is so fast that an accurate final schedule can be created during the preliminary design stage. Column scheduling in RCB consists of two parts. Firstly, design, letting the program try to find a bare minimum solution to AS3600. And two, rationalizing this design using design groups and user input values. The design table is where all information about the columns is displayed, including the results, and is where the design is rationalized. It will become the column schedule. The information shown in the cells can be customized, and reactions on the columns can also be shown. As a design has not yet been completed, only the column labels, dimensions, input material properties, and FRP are shown. RCB will, by default, modify all design parameters except for the column size in order to achieve a satisfactory design. In the Design Parameters tab, we set the global parameters for the design. Upper and lower limits are set for things like concrete grade and bar size and spacing. Individual, local column properties can be adjusted later in the design table. Think of these values as first pass values in the design. At a minimum, the column must be designed for strength. Fire, core confinement and shear design can be switched off so the user can get an indication of what is governing the design. The order in which parameters are modified by the RCB design is set in the Design Strategy tab. Different design orders will produce different designs which may be more or less efficient. For example, it may be more efficient to modify cover first for the fire design than it would be to increase the amount of steel to achieve a satisfactory design. Parameters can be switched off completely, and they will not be modified from the values set in the global design parameters. The old column design in RC Building only had 2 design strategies, whereas the new RCB column design has over 40 combinations. A design strategy can be determined that provides the most efficient design and a solution that is easy to construct. This, along with the design parameters, gives the user complete control over the design produced by RCB. Returning to the design table, a design is performed based on the input design parameters and design strategy. Results are displayed in a color scale for clarity. A summary report can be viewed for all columns, and a detailed report for an individual column can also be viewed. This will show all iterations of the design, so we have full transparency. Columns can be exported to RCC to look at an individual column. Individual columns that are failing can have their properties manually adjusted. These properties will be kept fixed during the next design. Rather than redesigning the entire job after manually changing the properties, only the individual column that was changed can be redesigned. The design process can be repeated a few times to get an indication of what is governing the design and give some guidance on how to proceed to the next stage, the rationalization of the results using design groups and user-defined values. The values so far are the bare minimum values to AS3600 based on the input parameters and design strategy. This will not do for a final column schedule, so the design must be rationalized. Using the color scale and safety factors, design groups can be created on the same floor and over multiple floors. The worst case design from the design group will be used for all columns in that group, and an updated safety factor will be produced. This way we can see if we really need to keep an individual column in a group or move it to another one. We can also start inputting user-defined values in the group to produce a final rationalized design that satisfies the requirements of AS3600. The process of inputting and changing design groups and user-defined values can be repeated several times whilst viewing the material properties to see how the changes that were made affect the quantity of materials. After a few iterations, a design can be achieved that is complete and efficient. Any changes that have been made to the columns can be committed back to the model. Through automation of the analysis and design process, RCB greatly reduces the time required to produce a column design and schedule. Through transparency of calculations and clarity of results, the user can be confident that they are producing the most efficient design using RCB.